Okay, so C, lecture 4. Today we're going to learn about basic algorithms, which is aka just sorting algorithms. So in this class we're going to cover, we already learned about arrays, but just go over that briefly again. And then we have bubble sort, selection sort, insertion sort. And then in the second half of the lecture we'll do quick sort, heap sort, and merge sort, which are the more advanced ones. Okay, so yeah, arrays. Arrays basically it's just an array of variables. Like, let's go back to our old hello.c. Oh, it's pretty beaten up. Okay, you know what? Let's just make hello2.c because that's how it works. Okay, great. So what is array? So let's say in the memory we have a variable. Why can't I draw? What the? Oh, let me do this again. Okay, let's see if I can draw now. Okay, yeah. So let's say like in the memory we have, okay, here's the memory. And in the memory, like when you make a variable, let's say we make int a, okay, it allocates a piece of memory. So we learned before there are pointers, right? So when we make an array, like an array is basically a pointer that points to itself, that allocated memory. So this is how it works, okay? Let's say we make int array, okay? So here's this, okay, let's just call it my numbers then. You know, let's just call it n, because, yeah. And then let's make it 10. Oh, you know, keep it simple, let's make it 5. Okay, there you go. So what this thing in memory is that, like, when I made n, it's gonna, like, make a pointer. So it's gonna get a piece of memory. And then this piece of memory is gonna be a pointer. But then this piece of memory is a pointer that points to itself. Okay? So let's say this address is 0, okay? And then inside it stores a pointer 0 which points to itself, okay? So why is this? Because like array is basically a pointer that points to like the piece of memory starting at n0. So like n has the same address as n0. Okay. So n0 is the first element in n, and then it goes from n0, n1, n2, n3, n4. So the 5 elements in the memory. Okay. Yeah, so that's what array is. It's basically just a pointer in the memory that points to itself and also points to like the stuff that follows it while within its range. So in this case 5. Okay, great. So yeah, okay, let's go back. Okay, so yeah, now we have this. Okay, now you know arrays. And then to access stuff in the array, we can just do like int a equals 0. So you just use the square brackets, and then every element in the array is the same type as the array type. So every element of the array, if it's int type, you just treat it like an int. And you print int like that. Yeah, easy. Okay, great. So access, we talked about that. Change is same as access. You just go to that thing, index, and change it. Okay, loop through, it's also similar. You can just put a variable in place of the index, and then change size. So remember, like in C, this is like memory have to be manually controlled by the user. Okay, so let's say if I make something like int a and then 100, and then in this case, it's just a pointer that's pointing to a random place in the memory that has 100 space reserved for this variable. However, if I print out like, if I print out a right now, this value is gonna be random because it's just in the memory and you don't know what it is because you didn't give a value to it. And also, if I try to access like, a okay, this thing is definitely out of bounds, right? Out of bounds of this. So if I try to make it to like 0. Likely the program is not gonna run. It's gonna crash. I mean, it's gonna run, but it's gonna crash because of this thing. Okay, so you should know that like the array, if you get stuff out of bounds, yeah, it doesn't let you compile. Let's see if I can still run it. Yeah, segmentation fault. You see, because it's out of bounds. So that's why you should be very careful to check if your variable is in bounds when writing C. Okay, this is not some Java or Python because your memory is like managed by yourself. You can also make multi-dimensional arrays, but we talked about that before already. So here's how 2D array works, and here's how you declare and define it. Okay, great. So now let's go skip to sorting. Good, bubble sort. Okay, so if I have an array of numbers, let's say I have an array like that, okay, int a, and then let's make it 10 equals to okay, 9 1 8 2 7 3 6 4 5 0. Okay, let's say we have this. So you can see this thing is not ordered. What if we want to sort it like in order? So what we do is that let's just use bubble sort, which is very simple. Okay, so here's how it works. So in bubble sort, basically you just compare every two adjacent elements. So you start from the beginning, compare, and then if it's smaller, switch. Okay, so let's just write that. So let's just loop through A, okay? And then let's just do that. Okay, so let's write if a I is less than a I plus 1. Okay, so now you see like I can go at most to 9, right? But if we access I plus 1, which is 10, it's going to go out of bounds. So here's when you be aware and you change it to 9. Okay? Then we do a switch function. So an easy way is just do this. Okay, here's an easy way to do it. So if I run this thing, okay, let me just print it out again. Let's just let's just do that. Oh, forgot. Didn't get to compile this thing. So as you can see, like after one turn, like every two adjacent values where it's like greater, it's switched, but it's still not sorted. So how do we solve this is that like every time the thing is getting more and more towards the sorted side. So what we do is that basically we just loops through this thing again. So let's just put this whole thing in a bigger loop. So it takes like n times to sort it. So let's just do that. So for an array of n elements, it takes n loops to sort it. Okay, so now you can see it is sorted. Yep. Oh yeah, also I forgot to print out the 0 because I forgot to change this. But yeah, we'll not forget the 0. I just forgot to print it out. Okay, yeah, there you go. You see? Easy. Okay, so great. That's how bubble sort works. Okay, bubble sort. Yeah. Okay, here's the example code. And here they use a swap function that is defined somewhere else. So here's the specs. The time complexity is that if your array has n elements, then it takes n squared time to do it. But then it only takes 1, which is like it doesn't take any additional space to sort it, which is very good. Okay, now selection sort. Selection sort is pretty good. I like it. It's because for every like element in the array, there's a part of it where it's like how do you say, like a part of it is sorted and then a part of it is not yet sorted, but actually like there's no difference. We just remember the index of where it's sorted and not. So we loop through the unsorted section, we find the minimum or the maximum value depending on how you want to sort it, and then we move it to the back of the unsorted section. So here we find 11, and then next you see we move 11 to there, and then we find 12, which is the minimum, and then we move 12 to here, and then we find 22, which is the minimum in the unsorted, and then we move 22 to here, and then we find 25, and then we move 25 to there. So you can see it's sorted. Okay, and the specs are same as bubble sort. Okay, so here's insertion sort. Okay, insertion is also a very simple sorting algorithm that works. Oh, by the way, I think the homework for you is to write your own selection sort. So where the hell did it go? Okay, homework is for you to write your own selection sort, so I'm not gonna demonstrate it here. Okay, now it's time to do insertion sort. Insertion sort is like basically kind of similar. It's also a very simple one, and I kind of like it because it's also split into a sorted and unsorted part. and the values from the unsorted part are like fine, like they're fine and placed into the correct place in the sorted section. So let's just skip to this diagram. Here we have a messed up array, right? And then messed up array, and then you can see it's not sorted, completely not sorted, so we start looping through it. Okay, first loop, we start with the second element, because there's no point starting with the first, because there's nothing before it. So we get this element, and then we just loop back, and then we see that 3, okay, is 3 smaller than 4? Yes, so we move 4 here, we move 3 here. Okay, next, when we loop to the unsorted, the next unsorted, which is 2. So is 2 smaller than 4? Yes, okay, move 4 there. Is 2 smaller than 3? Yes, move 3 there. Okay, so you put 2 here. And you go to 10. Is 10 smaller than 4? No, so you don't do anything. Okay, is 12 greater than 10? No, you don't do anything. Is 1 greater than 12? I mean 1 smaller than 12. Yes, so you put 12 here and you put 1 here. And then it's smaller than 10. Yes, 10 here, and then 4 go here, 3 go here, and 2 go here. And then 1 just stays there. And then 5. Okay, 5 smaller than 12. Yes, 12 go here, and then 10 go here. And then is it smaller than 4? No, so 5 stays here. Okay, next loop. And then you got 6. Same, and then you have it sorted. So how does it work in code? Okay, so here's how you do it in code. So let's just put away our bubble sort for a while. Okay, so here's how the logic works. Okay, let's just try to replicate the logic. Okay, so I'm gonna write the inner loop, which is like this one single loop first. Okay, so let's see. So first we have ai. So is it smaller than ai minus 1? And then because it's the inner loop, we have to start with no, we can just do this. We'll do it later, okay? And then we swap. So let's just copy this thing again and put it there. Okay, we put it there, and then yeah. Okay, so here's how the inner loop works. So it replicates the logic of one loop here, but then like as you can see, it loops multiple times. So then we gotta add an outer loop, and then because like we said, it starts with 1. So yeah, let's just do 1. So I equals j, and then j starts with 1, j less than 10. And then j plus plus. Okay, yeah. Okay, great. So yeah, this should work. Oh wait, no, not yet. Okay, if a is like smaller than that, then we switch, right? But what if it's not? If it's not, then else we just do after we swap, we just actually we don't have to do anything. Yeah. Okay, but there's a more optimized way to do it, so that's up to you. Oh, yeah, something went wrong. Haha. Let me check what went wrong. Oh yeah, because I forgot to change the inside of the swap function, Lamel. So as you can see, like it copied something out of bounds, right? Why is that? Why is this huge number? It's because it copied it out of bounds. So that's why you have to be very, very careful, or else your entire thing will break. So yeah. Okay, somehow the 0 is not sorted. Let me see why. Oh, it's because this. Yeah. Okay, what I did just there is because the outer loop is 1 less, so I made it loop 10 times actually, and then I just changed the logic there. So it shouldn't affect anything, but it should work. So as you can see, okay, why is it still not sorted? Oh, bro. Okay, made a mistake because it should actually go from this thing and it goes back. Okay, I forgot. I replicate the wrong logic, Lamel. Okay. Yep, like that. As you can see, it is what the hell. Okay, greater than 0. Okay, swap. Okay, copy something out of bounds again. So there's like these kind of like border value you have to be very careful of. So let me just double check what went wrong. Okay, yeah, nothing should be out of bounds. So Yeah, I don't see anything out of bounds. So, but never doubt the machine because the machine is always correct. So let's see. Okay, goes from 0 to 10. So shows here loops n times, and then it goes from the first element. Okay, first that. Oh, okay, bro. It's because it went out of bounds when this thing is 9 and then it starts at 10. So that's what went wrong. Yep. So yeah, perfect. Perfect. Everything works. Oh, here's the example code. Don't copy it. Don't copy it. As you can see, like it has the same specs as in selection and bubble sort, which is very good. And also, you can write it in 3 lines. So you can write it in 3 lines. I like this a lot, but it's not the most optimized. So let me just tell you here. For the swapping function, there's a way to optimize it. So optimize without swapping every compare. Okay, like if you can figure out a way to do this, like you don't swap every compare, you can actually make it a bit faster. Okay, actually not faster, but you can you can optimize it here to make it a bit faster. Okay, homework. Do array 2 times 2 matrix multiplication. Search up how to do matrix multiplication online. It's a math concept. And then also do 3 times 3 and then write this. Okay, and print out the results. Oh yeah, also write something to scramble an array and then you sort it. Here I'll show you how to do random numbers. Okay, and then okay, so yeah, this is a modulus sign. It's basically random divided by 10 and takes the remaining numbers, remainder. So oh, did I forget? Oh, it's not math. Oh god. It's it must be this. Oh, seriously, just run it. Yes, as you can see, I can do random numbers within 10. And here that's how you use random to scramble your array, and then you sort it. Okay, so that's the homework. Okay, great. So in the next part, in 4.1, we'll do quick sort, heap sort, merge sort. Oh, here's the challenge homework. Okay, pause the video and read it yourself. Okay, great. Email your solutions to me or DM, and also submit your solutions to that track sheet. Okay, yeah, great, thanks. Also part 2 of this coming out soon. Bye.